All right, we are a couple of minutes in, so let's get started. I'd like to thank everybody for joining us today. My name is John Weskett. I'm the Senior Vice President of Alliances and Marketing at Zixi and the Director of the Video Services Forum RIST Activity Group. I am joined today by Rick Ackermans, the founder and principal engineer of MVA Broadcast Consulting. He has been in the broadcasting industry for over 30 years, having spent 27 of those at Turner Entertainment Networks, holding various positions, including Senior Engineering Director for Transmissions and Chief Operating Engineer of WTBS TV in Atlanta. Rick is the chair of the RIST Activity Group and a member of the Board of Directors of the Video Services Forum. A fellow of the Society of Motion Picture and Television Engineers and a member of the SMPTE Board of Governors, Rick holds a Bachelor's of Science in Electrical Engineering and Technology from Bradley University. Today, he will present on enabling remote operations with reliable live video over unmanaged networks with RIST. So with that, Rick, please take it away.
Hello, everybody. Welcome and good morning or afternoon, depending on where you are in the world. And I'd like to welcome everybody here. Just saying hello. I'll turn my camera off so you can see the full screen video. But just checking in, so I didn't want to just be a disembodied voice. So hello, everyone. Okay, so this is an overview of RIST, which was something developed by the Video Services Forum. I'm Rick Ackermans with MVA Broadcast Consulting. I'm also the chair of the RIST Activity Group. This presentation was primarily put together and written by Sarah Narana from Cobalt Digital and Adi Rosenberg from VideoFlow, as well as the rest of the RIST Activity Group and the RIST Forum members who all participated in putting this presentation together. So today's agenda is what are the challenges facing technical decision makers in the broadcast industry? What can RIST do for me? What is the RIST Forum? A quick overview of RIST features and benefits, and an application scenarios and case studies of how RIST is actually being used today. So, what are the challenges facing technical decision makers in the broadcast industry? Well, with international contribution and distribution, there are many changes in the broadcast industry being pushed by management and often by finance and accounting. How do you solve these problems in a cost-effective way? Do you use private lease lines from regional telcos? They're quite expensive. They work. We've used them for decades now, but they are very pricey. They're point-to-point by definition, and the endpoints need to be serviced where they are. So it might not be easy to relocate. Even relocating across the street or relocating a block away can be very costly, costing thousands of dollars and possibly taking great deals of time to relocate the circuits. There's no flexibility in them. And you pay for the lines 100% of the time. They may be idle. You may only use them for 10 minutes a day, 10 minutes a week for a stand-up, but you're having to pay for those circuits full time or pay for switch circuits, which are quite pricey. But what about satellite delivery? Well, unfortunately, the C-band frequencies are being repurposed here in the United States and in many other places for next generation wireless devices. Also, in many cases, if you're using a large fixed uplink, you have to get to that location. So what is your first mile? So there need to be cost-effective alternatives. And now more than ever, with the 5G use potentially making C-band satellite no longer viable. For those who aren't in the U.S., I don't know exactly where everybody is, but here in the U.S., the plan is for the Federal Communications Commission to take about 2/3 of the spectrum that's being used and give it over to 5G. The problem is that the 5G may pollute the rest of the spectrum, making what's left not usable. So C-band satellite could effectively totally go away. and it's more lossy than the internet. So let's work remotely. Content providers are demanding the ability to work from remote production and content workflows. And as we've all seen, that's happening a lot more recently. We need to implement secure, low latency solutions over the public internet, which, once again, the public internet means non-managed service. And of course, as most of us, probably all of us, are sitting at home right now or some location, the COVID-19 pandemic has pushed this forward at an unbelievable rate. With all of us having to use internet to a degree we never imagined we would have to just 2 months ago. So what about the cloud? Well, there's cloud infrastructure. Many workflows are migrating to public cloud infrastructure and services such as AWS, Azure, Google, and all the others. The video needs to be moved around the cloud. For example, editing, transcoding, over the top, and playout. And there's trade-offs between upfront costs of the cloud storage bandwidth and versus permanent costs for fixed usage. The cloud can be very flexible, but as we've all learned, the cloud can also be very pricey. And can our services, existing services and equipment migrate to or integrate with cloud services? How do we operate in a mixed environment, whether it's on the cloud, whether it's point to point? How do we manage this? How do we manage and flow into this new world? So the question, and the reason we're all here is, what can RIST do for me? We're going to be a little dramatic there, but why not? So what is the problem? Well, I can use the internet as a cost-effective means of transporting high-quality, broadcast-grade video. But delivery through the internet is not guaranteed. The video may glitch. There is no QoS on the internet. So you have to be able to deal with whatever you have and take actions that are necessary in order to try and make certain you have enough bits flowing from point A to point B with low enough latency. It's not a private circuit, and you are at the mercy of other things that are going on. I need to be able to use any link or combination of links anywhere to move my content. Many solutions add a lot of latency. We've all seen the live cases where the person in the studio asked the question, so how are things going out there? And you watch the person wait and wait and wait, and then they respond. That is not a viable option when you're trying to do stuff that's interactive, when you're trying to do news, do sports, and other live content. And I also need my content to be protected so it doesn't get stolen. You don't want, if you have something that you want, it needs to be secure. You don't want it showing somebody pirating it and putting it on YouTube hours before you actually put it on air. And you also have to have a situation where bad people cannot hijack my feed and send their content instead of yours. I mean, whether we're talking, the old school from many years ago where you have a Captain Midnight intercepting a feed, or something far more, topical, like somebody Zoom bombing your feed, which has been an issue the last couple of weeks where people, intercept the feeds, get in the middle of it, and stick inappropriate content on people's feeds, to put it mildly. So it needs to be secure from both theft and from being hijacked. Also, my IT people are very busy. This must be easy and straightforward for them to set up. You can't have a situation where every time you need to bring in a feed, you have to contact your IT department, have a port open, have something set up so that it can check an IP address on an inbound or an outbound. It needs to be real time, plug and play and click, without having to have the IT department involved every time you're trying to set up a feed to or from a new location. So other people have solutions like this. A number of solutions that meet many of these user requirements have been available for a while from different vendors. And they're good. I mean, a lot of these solutions that people are all using work very well. I mean, we're seeing them on the air, and they make gorgeous video, and a lot of them accomplish a lot of what we are trying to accomplish with RIST. However, why is RIST different? Well, RIST is a joint effort between many of the leading companies that provide video over the internet. Experts with hundreds of man-years of experience freely contributed to this effort. Best-of-class technologies in every aspect of the protocol, while following established standards. And I'll point that out. RIST was not, we have not created things new. With RIST, we've just taken established standards, RFCs, and stuff like that, and actually used it. I sort of used the Lego approach. We looked at what building blocks were out there and put them together into an interoperable product. And as it points out, as the final line here says, the final choice is yours to pick the best equipment. RIST is interoperable. So you are not locked into any one vendor, as much as a lot of the RIST partners really wish you could be. If you buy something from company A, you can use it with something from company B. Or somebody else has something from company A and you need to bring in a feed from them. You can use it among all the different partners in RIST. So you're not locked into a proprietary solution. You don't have a situation where you've got a truck out there or a stringer out there trying to feed you something and you don't have exactly the right version of the product or the right company's product to be able to receive the feed they're trying to send you. So who's behind RIST? Well, we have the two primary groups. We have the Video Services Forum, which you can see if I'm over here on this side, the Video Services Forum, and that created the RIST Activity Group. The RIST Activity Group, they're the ones who deal with the standard. All the technical stuff involved with creating RIST has been done by the RIST Activities Group. On this side, you have the RIST Forum. On the right, they're the marketing arm. So we decided to separate the technology portion of RIST from the marketing side of RIST because the Video Services Forum is not a marketing agency. It's an industry trade association and a technology group. And so therefore, they decided that it was best that some entity other than the Video Services Forum handle the marketing for RIST. So that's where the RIST Forum came from. So if it gets a little confusing to people between the VSF and the RIST Activity Group and the RIST Forum, the RIST Activity Group and the VSF deals with all the technology. The RIST Forum deals exclusively with the marketing. If you have a technical issue or if you have something you would like to see incorporated technically into RIST, you would deal with the RIST Activity Group and the Video Services Forum. So that's how that is set up. Now, one little side note here. I did not put this slide together. It was actually done by Adi Rosenberg. But when I looked at it, I noticed on the RIST Activity Group side, the person at the head of the table over here appears to be a redhead. So I decided that that must have obviously been intended to have been me. And it may just be my opinion, but I thought, you know, they have a redhead at the head of the table. So I said, oh, I guess that's me. Like I said, little side note. The leading members of the RIST Forum, and the RIST Forum members are more expansive than the RIST Activity Group because they include a lot of users. But you can see a list here of the principal members of the RIST Forum, and all the technology companies here that you see, or most of the technology companies, are also members of the RIST Activities Group. So as you can see, you have a wide variety of companies, of manufacturers, and of users and transport providers who are members of RIST. And it is open. If you are a manufacturer or a transport provider or an end user who wants to be actually involved with the creation of RIST, feel free to join. You can join the RIST Forum, or you can join the VSF and become a member of the RIST Activities Group. We are looking for more participation, and we are an open group, and the more participation, the better. It's not just a matter of, you know, people of an entity that says, here it is, use it. Be an active participant. Feel free. So an overview of RIST technology. The timeline of RIST began back in February of 2017 when the RIST Activity Group was created within the VSF. And that originally came about due to a request from ESPN, which had requested some standardization of a lot of the live contribution technology. So in February 2017, the RIST Activity Group was created. The first draft of the simple profile came about in April of 2018. And then in May of 2018, we did our first interop at VidTrans, where we showed that the stuff could actually work together. We did a second draft based upon the output of the interop in July of 2018. And then we did our first public interop in September of 2018. So about a year and a half after we started this whole process, we did our first public interop. Then in October, the simple profile was published. And it was also at that point, right after that, that the RIST forum was created. And that's when we had this profile and decided, okay, how do we market it? How do we distribute this information? So that was the creation of the RIST forum. In April of 2019, the first commercial products were available, publicly available. Actually, that having been said, in reality, as RIST was being developed, since RIST is primarily software, many of the member companies were actually incorporating many of the RIST features into software updates for existing products prior to its formal publication. Then in September of 2019, we started work on the main profile. And then the main profile was published in March of 2020. In a little bit, I'll get into the differences between the simple profile and the main profile. And just so you know, we are beginning work on the advanced profile, which work is continuing on, and I will get into that later, or for that matter now. So here's the roadmap. So the simple profile, hopefully you guys are seeing me move my arrow around. This has the interoperable ARQ. For those who are not familiar, ARQ is the technology by which most live contribution streaming platforms work, both the ones that are done by groups of people and the individual. ARQ, in its simplest form, is a process whereby if the packets are sent and they don't get through, you send them again. But more on that later. So simple profile involves interoperable ARQ, retransmission, throttling for stability, link aggregation and bonding, and redundant transmission paths. Then we came up with the main profile, which we just launched a couple months ago, which involves multi-stream tunneling, stream encryption, authentication, high bitrate support, and null packet suppression. Now, the enhanced profile is what we've just begun work on. We've only had about 4 meetings on this. Our timeline for the advanced profile is that it should be available next year. We expect it to be shown at VidTrans in February of 2021, whether that's at VidTrans in Marina del Rey or virtual VidTrans online. Time will tell. That will include smart bandwidth optimization, a common channel session management, a centralized call home so that you can control multiple feeds from a central location, and a support for a hybrid internet satellite operations, which gets into what can be done with if you have to migrate from C-band to, say, KU or KA, and how do you operate in a hybrid satellite terrestrial fiber/internet environment. So the RIST simple profile, and this has been available for a couple of years. It has a base stream standard of RTP, compatible with non-RIST devices. So in many of the proprietary formats that are out there, a lot of them, you can actually use a base standard RIST and actually communicate with many of them. No guarantees if it's not RIST, but in many of cases you can. And the features include packet recovery using ARQ, which won an Emmy Award a couple of years ago for high performance. And we've been able to demonstrate that it can actually operate with up to, and in many cases even exceeding, 50% packet loss. So if you're on a very lossy internet connection, you can make good, reliable video that you can use for contribution. Many of the other formats out there cannot handle that level of packet loss. And with the internet, there is no QoS. You're at the mercy of whatever it happens to be. It has multi-link support for bonding. So for example, you can use a terrestrial cable modem and 4G. You can use a corporate internet connection and a cable modem. Whatever combinations you feel you need to use, you can use. And companies are free to innovate with their products as long as they don't lose compatibility. So we allow them to make adjustments and modifications, but the rule is if you are in RIST mode, it has to be interoperable and you must remain interoperable. And you must support interoperable RIST modes on any RIST product. But that's not to say that if you come up with something special, something that's a little bit better, that you can't have some non-RIST modes your product does not have to limit itself to only what is RIST compliant. If you want to go into a non-RIST mode and do something that's possibly more spectrally efficient or has some other proprietary benefits, that's fine. We're not saying your product is not allowed to do that. You just have to keep compatibility when in RIST mode. So the main profile, well, we've included tunneling. Multiple streams can be combined into one UDP port, which includes a simple IT configuration for multiple channel operation, be that for multi-cameras or even completely independent streams. And there's no limit as to how many streams can be in the tunnel. The connection can be initiated from either endpoint. It does not have to be sender to receiver. It can be receiver to sender. That simplifies IT configuration. You don't have to have a situation where the receiver has all the ports opened and configured. You can have more flexibility on your sender and originate the stream the other way. It is a fully bidirectional, and it has full support for any type of out-of-band IP data, pan-tilt zoom controls, anything you need, or in the case of what I've had to do previously with sports, shot clock and scoreboard data. Whatever you want to send along with the video, you can send any kind of ancillary data along with it. It supports encryption, which is very important. The simple profile did not, but we do support encryption. It supports top of the line AES, and RIST uses existing DTLS encryption, which is similar to encryption stack used for many web applications. I know some people later on are going to say, why'd you use DTLS? It was a committee decision. We had lots of good options. It wasn't that we didn't have good encryption options. We had lots of them, but we opted to go with DTLS because it met the security. It was stuff widely used among the internet, and it has the advantage of having quick recovery. One issue that a lot of encryptions have, if you have a glitch on the internet, you want your glitch to recover as quick as possible. We didn't want to use an encryption format that increased the delay time if there was a glitch. We didn't want to have a situation where you had to wait 2, 3, 4 seconds for your video to come back from a minor glitch because the security was doing handshaking and we were waiting on security. Obviously, waiting on security in case you do have a video glitch. Video glitches are bad, but if you have one, you don't want to be waiting on the security. It does have support for a pre-shared key. It doesn't have to use the pre-shared key, but it is available. And that was also done for reliability. If you're doing an ENG application or a point-to-multipoint, there was some discussion of not having pre-shared key for security. But if you're out there doing an ENG shoot, you didn't want to have a situation where you didn't have some quick and reliable method of security, where your only option was to completely turn security off in order to get that feed in, especially if you have a stringer doing a news video. So that's why a pre-shared key is included, even though there are some security folks. It was a trade-off between security and practical applications in an ENG environment. Authentication guarantees that whoever you're connecting to the endpoint through the internet is who you think they are. So you don't have your feed hijacked. Authentication guarantees that when you connect to someplace, it's the place you think it is. Now, RIST uses the same techniques used to guarantee that when you connect to a bank, you're really connecting to your bank. Certificate pre-authorized in both server and client, password authentication for simpler cases, multi-factor authentication if needed. Other key features: support for bandwidth optimization using null packet deletion. Transparency normally can reclaim 5% of stream bandwidth. Reclaimed bandwidth can be used for packet loss protection, ancillary data, whatever you want. Obviously, if you're dealing with an environment where you have limited bandwidth, you don't want to. You do it with a whole lot of null packets. Support for high bitrate operation. There is no high-end cap on the data rate. So the question is, how big a path can you have? And the answer is, whatever your hardware can support. There is no limit. You want to do gigabytes? If you've got a gigabyte path and your gear has a fast enough speed that it can process it, there's no reason you cannot do any bandwidth you want. There is nothing necessarily limiting your bandwidth in the standard of RIST. Now, RIST is built on common RFCs. There is not proprietary stuff. Whenever possible, we found existing things to use in RIST. Both SMPTE standards, such as 2022-1 and 2, and for transport over RTP baseline, 2022-7, seamless switching for multipath use, as well as several IETF RFCs. You can see the whole list here of all the RFCs used for RTP, PAC and NAC acknowledging, tunneling, JSON, tunnel management, PSK encryption, DTLS encryption and authentication, encoding of certificates, password authentication, and PSK key generation, all based on IETF RFCs. Once again, we did not make new stuff up. We put existing pieces together. So RIST products. You can buy RIST products from multiple vendors. It's not just one provider. There are many of them out there. And as I've said, if you're an equipment manufacturer who's interested in incorporating RIST, feel free to contact us. We are looking for more RIST partners. Encoders, decoders, gateways, conversion between RIST and other protocols, system integration with system integrators with experience, and RIST services in the cloud. And yes, RIST does run in the cloud, can run in the cloud. It's available right now in AWS Media Connect, among others, not plugging one, but they have been one of our early members. So you can run it, it can be run cloud-based, encoding, decoding. All that stuff is doable. There is open source RIST. The main one we are pushing is LibRIST, as well as other manufacturers who have open source applications if you want to use it in the cloud. It's also available on VLC and Wireshark. Currently, you can use the latest build of VLC to run the simple profile, and at some point we will be incorporating the main profile once the next full update of VLC comes out. And there are plugins available for Wireshark. But what if I need help from with RIST? Well, first of all, there's technical discussions take place with RIST. We have a Slack, video developer Slack. You can see the URL here, www.video-dev.org. There you can discuss your technical questions with dozens of RIST engineers. So we're out there for support, both for end users as well as people trying to incorporate RIST into products, or open source RIST into apps. Now, okay, to deal with the elephant in the room, people are always asking, well, what about SRT? Personally, those who know me, I don't like, face-to-face knockdowns, but everybody's asking the questions. So I will deal with the issue as far as RIST versus SRT. RIST is designed jointly by industry experts. SRT is designed primarily by one company, which to a large extent dominates it, whereas RIST is totally open. If you want to join RIST, you become a free and equal partner. It's based on Stream RTP, compatible with many existing devices. Its design is based on UDT and UDP data transfer as a file protocol, and multipath support. It has bonding to combine multiple paths for higher bandwidth, and seamless switching, whereas the currently built version of SRT does not have multipath support. So ARQ, yes, both of them support ARQ. High bandwidth support, yes, theoretically. Forward error correction, yes. Null packet compression, RIST, yes. SRT, no. Encryption, PSK to 256 bits. With RIST, you have up to 256 bit, and we stress the up to. We have to have support for lower data rates of RIST encryption because there are some countries that do not allow you to use 256-bit encryption. So for those countries, you can have a version of RIST that only supports 128-bit for legal export and use there. Once again, service reliability, we support tunnel bonding within RIST. And we have standard support for certificates using TLS, SRP, whereas the SRT is using a proprietary authentication. So SRT, our folks have found in the lab, stops being effective at 12 to 15% packet loss, whereas RIST can achieve 20 to 25% packet loss if you have short instantaneous peaks of 100% overhead, and it can correct 30 to 40% packet loss if you have short-term peaks of 200% overhead, and packet loss rates even beyond that, which we will show in a moment. So we have the Cloud RIST demo. Currently, we have a bunch of servers in these locations, both in Europe and the United States, all going back to a cloud-based server, a bunch of blades sitting down in Florida. We have various transmitters ranging from open source LibRIST, Evertz, Nevion, Zixi, Cobalt, Qvidium, VideoFlow, SIP-Radius, and NetInsight going back into the data center in Florida. And if you want, and this may be in the handout, and you can actually look at it yourself at this URL right here. We'll make that available later, but it's up and running right now. Now I'm going to show you what it looks like. Now you're watching this on Zoom, so you're going to see some freezes. It's not, obviously the server is not actually freezing, but that's what that is from the Zoom feed, which is probably what you're seeing. So this is live right now, coming over the internet, coming from all the locations shown on that data from all over the United States and Europe, coming back to a data center in Sarasota, Florida, and all this is being done in the cloud and being regenerated and streamed out at 1080. And these are all live feeds. Like I said, I know you're seeing some freezing due to the Zoom meeting, but if you actually go and look at it at the URL, you will see this is running at 60p and looks really good. And now back to our featured program. So here's something we found interesting. We talked about 50% packet loss. Well, for short periods, it can go way beyond that. This was actually something that was measured. This was off of a cable modem, and it shows a RIST stream going between Cobalt and VideoFlow, and that it had a short period packet loss of 86% due to the burst loss. This type of loss is common with TDM on cable, where you're sharing bits with all your neighbors on the same node. So over very short periods of time, your neighbors may get the bits and you don't. And this shows a normal operation with a very short duration packet loss of 86% and absolutely no drop bits. So the ARQ was perfectly capable of recovering all those losses for a short period of time. Once again, real world environment using cable modem. So RIST use cases. Well, we have bidirectional transport, where you can have video feeds and ancillary data going in both directions. Diverse path load sharing. So you can have a 4G service up here and regular Wi-Fi or any combinations you want. And if you drop a packet, you can configure how that packet is sent via ARQ. Does it send it again via the same path? Does it send that packet via your secondary path or another path? Does it send any lost packets via both paths? ARQ can also work positive or negative with either positive acknowledgement or negative acknowledgement if a packet was received. Seamless switching. So if you are not, so if you lose a path, whether it be a 4G, a Wi-Fi, a hardwired fiber, RIST, when it sends the ARQ acknowledgement back, it can also use a 2022-7 to completely switch your transport over to the other internet path. So you can lose paths and have noisy paths and not have any visible loss. As we said, you can, as I said earlier, you can also use remote PTZ, as a lot of folks are having to do right now. So over that RIST connection, you can have somebody at a remote site, whether it's a studio in some other city, or as is often the case right now, their basement, and you can use RIST to remotely control all the features, the PTZ camera, CCU functionality, any data you need to send back. It's fully bidirectional. You can use it for multicast distribution with LibRIST. Now, the internet is unicast. However, the tunnel supports multicast. So within a unicast tunnel, you can send a multicast stream. Also in the cloud, if you have a hardwired connection, so as you say you have a private cloud or you have a dedicated connection to the cloud, at that point you can take that service and transcode it down to a multicast. It is multicast within a unicast tunnel. That also allows you, when you get back to a LAN, you can have a device that takes that unencapsulates that unicast tunnel and gives you true multicast on your local LAN. So RIST supports multicast even though the internet itself does not. You can use it for playout from server to multiple points. So here are some simple RIST deployments, sample RIST deployments. Not simple, sample. This one is Mankin Media. They have multiple locations. This is not a broadcast app. This particular entity is a company that runs stuff for both broadcasters and other users of video services. And they're using RIST to go to their transcoding for both distribution and live monitoring and potentially control of it via their Guardian service. And yes, this is a plug, but they're a partner. And Lockwood Broadcasting is currently using it for field contribution and interconnects between their various stations. It is used to go from remote sites and stations into the cloud and into their private servers, and from there back to stations and other locations. So you can go from any point to any point. And if you need to go to multiple points, you can, obviously, if you have a cloud service provider, as I said, you can go to multiple unicasts. For further reading, you can go to the various websites, the VSF websites for TRO 1 and 2, a RIST activity group webpage listed here, the RIST forum for other events going on, RIST performance measurement study presented at the 2019 NAB, as well as demos from IBC 2018, VidTrans 2019, IBC 2019, SMPTE 2019, and VidTrans 2020. Thank you. We will now open the floor to questions.
We've got a couple of questions in. Is there an ability to switch between streams in the cloud? For example, an entirely cloud-based clean video switcher?
Well, as I showed in the demo, you can, well, let me call up my multi-image here. You can do whatever, while RIST itself does not do that. As you can see here, you can do a multi-view in the cloud and all that. Now, while the multi-view is somebody else's software, it's not part of RIST. There's no reason you cannot do all that stuff in the cloud. You can do anything in the cloud you want, like I said, including a multi-image viewer with graphics on it. So switching is, I guess, I would say relatively easy compared to this. So I guess that's a yes, even though it's not RIST software specifically that does that.
Is there a mechanism to turn off the tunnel or limit bandwidth when the stream is not being used?
Yes, it can support adaptive rates. So it's simply, you can turn it off, you can throttle it down. It's not hard coded. That's an end user function of the end deployment, but it's perfectly capable of reducing the bandwidth down to, next to nothing or completely muting it.
How do you compare the expected latencies between SRT and RIST in equivalent conditions?
That largely depends on your, well, in equivalent conditions, I would say they are somewhat comparable. They're both using ARQ at their core, and it's largely a matter of how long it takes for retransmission. Now, you do say comparable conditions. We do allow multipath support, which SRT does not. So, you can have multiple paths, which obviously can improve your ability to get paths through and not need as many RTT times due to dropouts. But under ideal conditions, which would mean a single link, they're comparable.
And as Haivision is the primary maintaining a body for SRT, why are they a leading member of RIST?
Well, RIST is an open group, and so anybody is free to join, and they've actually been good participants. I cannot answer anything as to why SRT does anything, but it's another product, and they've decided to have both products at this time. And I'm just speaking as an end user. I once again cannot speak for Haivision or SRT.
What is the timeline for finalizing the main? I think that's already out, but advanced profiles.
The advanced profile, the target date is to have it up, running, and operational at VidTrans 2021, which would be in February. So we expect to have, so that's our timeline, and obviously show it and have products available from the various vendors at NAB 2021.
How much latency can be expected from the transfer to the receiver?
It's a matter of your RTT time. So if you're going, within a city where you may have a ping time of potentially 10 milliseconds, you're looking at least 3 RTT times your RTT. Some folks have said 5. It depends on your quality, but you need probably around at least 2, probably 3 times RTT at a minimum. So obviously your latency going from 2 places within an urban area is going to be less than your latency going from New York to LA or New York to Tokyo. So it's a matter of your internet connection and multiples of your RTT time.
Has the CPU requirement for each RIST profile been quantified?
Not totally certain what the question is. I mean, obviously, depending on the functionality you use and what other functionality is running on the same cores, it's going to take CPU cycles. As far as do we have a chart for this mode requires this CPU, it'll take these many cycles. Not published within RIST. It's entirely possible that some of our members have done that, but we certainly don't have that specifically published anywhere.
Are products claiming RIST compliance required to support all RIST features, or can they be selective?
They must support the full layer. So what they will, if they say they support RIST main profile, they need to have interoperability to it. Now, as we start getting into some of the stuff in the advanced profile, well, I'd have to rephrase that. I would say they can be selective, and I'll just bring that up as an example, because obviously multipath support. Well, if you don't have dual NICs or something, you're not going to support multipath. The software will support it, but if you only have a single, network interface, then you're not going to have the dual path support. So you can be selective in what you support to that extent.
How do we find out more about basic, main, and advanced profile support?
There are these websites here have a lot of, most of the information that people are looking for. We have back several slides, we have the developers page where I put the URL out. And you can contact any of the, you can go to the website of the Video Services Forum or the RIST Forum, and there are links there for sending in your questions. If you send it to one entity and it's something for the other entity, we'll forward it on. But I would say check out the RIST Forum website or the Video Services Forum website. You can Google those, and there are links for your questions.
All right, and we have one last question. Is there a threat to the RIST protocol from things like 3G or 4G mobile streaming solutions?
A threat? No, I'd say there's most of the, okay, so you're talking about the video solutions in them. Well, obviously, we've seen recently on TV, we've seen every video streaming, consumer video streaming format known to mankind used in programming the last couple of months. So yeah, all of those are things that can be used, but you've probably noticed the quality of what you're seeing, and we can support a higher professional quality than you can with, well, I'm not going to name the names, but we've all seen them plugged over time. It's great when you can just open up your smartphone and use the app that's already there, but it doesn't support the professional level of quality that we would like to support, certainly in more normal times. But yeah, there's certainly competition from the consumer formats.
All right, thank you, Rick. Thank you, everybody, for attending today. We will make the link to this webinar available to all of our registrants and attendees. And if anyone has any further questions, Rick, if you want to go to the last slide, we have info@RIST.tv. So please send us a message. Thank you.
And thank you very much, everybody. Have a good day or good evening.